Happy Monday, everybody. Today is 1.6 least common multiple, and we're going to continue to take off on our theme of the cake method here that we learned with greatest common factor. But now we're going to use it for least common multiple. Remember, multiples are numbers that are shared by two or more numbers. Multiples that are shared by two or more numbers are called common multiples. The least common multiples are the LCM, which we're trying to find. So like a multiple of 3 would be 3 times 1 is 3. So 3, then 6, then 9, then 12, right? Those are the multiples of the numbers. So once again, I'm going to show you two different ways here. I'm going to show you the common way that you used to do it, and then I'm going to show you the cake method way. And again, there is a way you can use it using prime factorization, but as again I said, I think most students find that too confusing. So I'm going to skip over that one for now, and we're just going to work on this. So find the least common multiple of 4 and 6. I already know what it is in my head, and you may do as well, but I'll show you how normally we would do this. Normally, when we list out multiples, we would start with, we'd take the 4s, and we'd list out the multiples of 4, and that would be 4. Then 4 times 2 is 8, and then 4 times 3 is 12. And then we keep going to 16, and usually I write out the first 5 to start with. But, I mean, everyone does it a little different. And I'll do the same thing over here with 6. I'll do 6, 12, 18, 24, and 30. Now we look for the multiples here, the smallest, least that they have in common. 4 and 6. Here it is. I think it's right here. 12. Right? 12 is in common. Absolutely, that is the correct answer there. If we would continue this one by one more, we'd get to 24. They are common multiples, but it's not the least common multiple. 12 is the least common multiple, so over here I can write 12. So that's one way you can do it. But as the numbers get bigger, it gets a lot harder to try and figure out the least common multiple and trying to do all that. So, I mean, that's really up to you as you go forward, what you want to do. As I said, I'll accept either one. Oh, look at that. Old stuff I never erased. Alright, so I'm going to use a different color for this page. Prime factorization. We're not going to use prime factorization. I already told you that. So, there was a time, and then that I might have shown some people that, but it's not worth it, especially when we're not meeting in person for this. I'm just going to stick with cake because I've just gotten to love cake more and more here. So ignore that down there. 16 and 20. Cake method doesn't change. You write down the 16, you write down the 20, and we're going to do the same thing we did before. We're going to pull out common factors. The first thing I saw was 4. 16 divided by 4 is 4. 20 divided by 4 is 5. Nothing comes out of 4 and 5. Here's the difference with LCM and GCF. GCF, we would just look at the icing, right? 4 is the greatest common factor, and that's true. But here we're looking for the least common multiple, so we're looking for numbers bigger than this. And notice, by the way, that this is L, right? L, least common multiple, right? Well, what I'm going to do with the least common multiple is look at the L in my cake. I'm not only looking at the icing here, but I'm looking at this base layer, right? And this, I mean, you can see it kind of makes it's a weird looking, but it makes an L, right? That makes this L right here, right? Oops, I didn't want to do that. I just wanted to undo what I did the last time. All right, so 4, I said it was 4, 16, I'll just redo this real quick, 20, that was 4 and 5, right? And what I said is now we're looking at this L. Ooh, that's a terrible thing there. That's a terrible drawing. I don't know what that is. Alright, so at any rate, so to find the LCM, we are going to multiply this L together. So we're going to do 4 times 4 times 5. Alright? And because one of the things I know is it's all multiplication, I can go in any order here. So I'm going to do 4 times 5 and get 20. And 20 times 4 is 80. So 4 times 4 times 5 is 80. So the least common multiple of 16 and 20 is 80. Boom, there you go. It's fantastic. Works really well. Alright? And so you can see where this, 20 is not so hard to list out the factors of, but 16, it might start to get a little tedious to start listing out all those factors. So that could be a little bit of a time saver here. Sorry, so we're going to do one more here, cake method, 16 and 22. 16 and 24 rather. And again, we're going to hit up 16. We're going to hit up 24. And again, for me, the first thing that I see is the 4 that comes out. 16 divided by 4 is 4. 24 divided by 4 is 6. Oh, they're still both even, so I can do another layer of cake here, which is good. 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Now I know I'm done. I can't do anything else with that layer of cake. I can't believe I just did that. Let's just erase that. I'm gonna fix that up. Alright, so now here's the L, right? We look at these numbers here. And now I'm going to do 4 times 2 times 2 times 3. If I multiply all that together, I'll get the least common multiple. So 4 times 2 is 8. 2 times 3 is 6. 8 times 6 is 48. Now, because it's all multiplication, you can go a little crazy with your order, right? The order of operations technically would say you should do this first, then go do this, then do this. But because it's all multiplication here, I can kind of chunk it together how I want and still be okay. So 16 and 24, the least common multiple is 48. And what I find nicer about this as opposed to listing out the multiples is you don't have to worry about messing up like 16 times 3 or whatever. You're dealing with all smaller numbers and it's a little bit more easy to manage. But again, you can choose which way you like. Alright. Heading on out to number 4. LCM of 4, 15, and 18. And it's good to see this because we can do 3 here, and there's a little difference in the 3s in LCM versus GCF. This is the one thing that you kind of going to have to remember because this is going to be different. Right? Let's use some purple here. All right? 4, 15, and 18. When we were doing GCF, because had to deal, because of the way we had to deal with that, right, it had to come out of all 3. Well, with LCM, as long as a factor can come out of any 2, I'm going to say that again, as long as a factor can come out of any 2 numbers, you can take it out. So if I look at all 3 of these, I see nothing in common for all 3, but 4 and 18 have something in common, and 15 and 18 have something in common. So you can take it out. And when you just take it out of the 2 that are in play here, and that's just a matter of the difference between multiples and factors. So I'm going to take out a 4 and 18. I'm going to take out a 2. And when I do that, 4 divided by 2 is 2. I didn't take it out of 15, so I just bring the 15 down. That stays the same. 18 divided by 2 is 9. Now, is there still something I can bring out of any 2? Yes. 15 and 9 I can take out of 3. I'm not touching the 2 here, so the 2 stays the same. 15 divided by 3 is 5. 9 divided by 3 is 3. And now, there's nothing that comes out of any of these. So now I know I'm done. And now I'm going to multiply this all together. Right? 2 times 3 times 2 times 5 times 3. Okay. So what I'm going to do, I'm just going to start chunking this. This is going to be 6 times 10, 2 times 5, right? Times 3. And then I'm going to do 6 times 3, get 18 times 10. And this will be 180. Now imagine how many factors you'd have to go out with 4 to get to 180, right? Or 15 to get to 180. 10, right? For number 18, you'd have to list out 10 factors. How quickly do we just do a 3-number summary? The thing, though, you have to remember, right? And this is, again, one of the key differences in what we do with LCM and GCF. If LCM you can take out of any 2, GCF it has to come out of all 3 because of the difference between factors and multiples. Okay, so please do keep that in mind as you go forward. All right. All right. So we're going to keep on keeping on and head to the last problem. Right? And you're going to see word problems, right? Right? Think about, and in your IXLs, you're going to see GCF and LCM word problems mixed together. To try and figure out which one to do for what, think about what they're asking. Are they asking for an answer that's going to be bigger than the numbers you're given or smaller? Right? So you look at this, right? Traffic light changes every 30 seconds. The other traffic light changes every 40. Both lights just change. How many minutes will there be before it happens again? Right? So you're looking at seconds and they're talking about minutes. This is going to be a bigger number. Right? It's going to be bigger. It's not looking for something smaller. If it's looking for bigger, you're thinking multiples. If they're talking smaller, it's going to be factors. Right? So you have to think about that as they present that to you. All right. So let's get this out. 30 and 40. Ooh, it would help if I give myself a color here. I didn't. 30 and 40. And obviously for this one we know it's going to be multiples because it's in the multiple section. But for IXL, they're going to be mixed together. And you have to ask yourself, is it asking for an answer that's bigger or smaller? Like you think back to the pinata problem from the first one. They give you all these candies and they say, how can you break these candies down to fit into the pinata? Well, you're not going to get more candy to fit into the pinata. You have a set amount of candy, you have to break it down and fit it into how many pinatas, right? So that's going to be a smaller answer. Here, in this case, we're extending these numbers, so it's going to be bigger. All right, so I'm going to bring 10 out here because that's the thing that I saw first. 3 and 4, we are done already. So it's just a matter of multiplying these numbers together. Remember, that makes your L, right? So least common multiple, you do this L, right? Least common multiple. It's a weird shaped L, don't get me wrong, it is weird looking. But how do you remember when using cake method, when to use the bottom numbers and when not to? When you're looking for least common multiple, you use the L. Alright, so it's going to be 10 times 3 times 4. I'll tell you, anytime I have 10, I always try and save that for last because it's easy to just tack on a 0. So I'm going to do the 3 times 4 here and get 12. 10 times 12, just add a 0, is 120. So, after how many minutes? Well, both lights change at the same time again. The answer is going to be 120 minutes. Hopefully you were catching me on this. Right? It's not going to be 120 minutes. 120 is right, but it's not going to be 120 minutes. Why is that? Because they gave us the numbers in seconds. So this is 30 seconds, this is 40 seconds, which means this is 120 seconds. So, if I want to change the seconds to minutes, I have to divide by 60. 120 divided by 60 is 2. And so my answer is 2 minutes, or 120 seconds, but they asked for your answer in minutes, so your answer should be 2 minutes. All right, folks, that's it. Hope you got it. Hope it's good. And if you have questions, feel free to let me know. Have a great day. Have a great Monday. IXLs, don't forget, you have 2 of them today, due tomorrow. IXL numbers NGA and ZB8, right? So I will quickly throw that up here for you. That is NGA, and you know where you can find this as well. NGA and Z as in zebra, B8. All right, folks, have a great day. Good luck. I'll see you later.